Welcome to the Decode Podcast with Elias Malfovan, Daniel Stanfill, and Sean Kincaid.
Welcome back to the Decode Podcast. We are here at SMTA International in beautiful Rosemont.
Yeah.
It's kind of cold out there.
It's a little windy.
And we have Miles Moreau with Kick with us. He's a fellow San Diego native, or at least that's where he is now. I don't know where you started, but
close enough. Southern California boy.
Southern California boy. So welcome, and hope to have a chat about all things profiling and free flow and thermal significance and all the above.
So I'll do my best here to let you shine. Let me tell you the likely inadequate way that we profile, and you can tell me what I need to do better. So frequently we won't have disposable components and boards that we can just burn. So I will take a bare board and tape the thermocouples to the most thermally important parts.
With Kapton tape?
With Kapton. No, not with Kapton. With that
aluminum tape?
Silver aluminum tape, whatever. And then run it through, measure the profile and all that. But how much different and better is it when you can actually do that on a populated board versus just the bare board?
Well, it's significant.
Yeah.
So, and it just depends on the complexity of the board, how much variation you have on it when you add connectors, or connectors compared to passives and that sort of thing. So it's almost better if you have some type of scrap board that is similar enough to do that, because the mass and the density on the PCB.
Well, you've populated with a bunch of little heat sinks, essentially, right?
You could even do that, and that might, I know probably from our customers, I would say a majority do the same thing you just described.
Okay.
It's a bare board.
Okay.
So, and then if it's significant, where after you're putting a certain amount of paste on there, which is impacting it, just even doing a board that is not freshly printed, there's a difference, because the reaction of the paste compared to an already soldered board, and you're measuring that solder joint, you're even getting a difference between that.
Sure.
So it just all goes back to, how can I simulate a production board as much as possible?
Well, what I like about the software, I'm a Kick user, right? So I'm going to talk about my experience. What I like about it, though, is it learns your oven over time, and you can take actual pictures of the populated board, right, as well as bare board. But then also you can get the weight of that board as well, right? And then you can kind of, as you're building your profile, the guesstimate part kind of goes away a little bit. So if I know that it's going to be around this weight, and it's going to be this dimension, and this is the pace that I'm using, over time I get a nice learning feature on it.
It gives you a good baseline to start, for sure.
Yeah, and that's one thing we've tried to do. All the profilers out there are capable devices. So we always try to keep our profiling device kind of current with the capability of sampling, temperature tolerance, and all that. But where we add value is in the tools we have in our software to, go up against these problems that our customers have. So with regards to what you're talking about, Sean, is being able to have the system learn, right? Have a learning system where you can put in dimensions, and then it'll give you that first guess. Because if you just use the bare board, come up with your own first guess, then you're going to have a fantastic profile for a bare board.
Yeah.
If you do have a little bit of an indication of, I know I'm putting this much paste down, and based on my Gerber data or knowing the population, I'll add, this amount of grams onto the board. Then the first guess on the system is using all this previous data from that oven. And that now your starting point. Now, it may not be that your bare board profile with that recipe that the system gave you is as in spec as if you tweaked it yourself. but it's more towards what the production supports.
So that'd be
Gonna want.
interesting to take a bare board, do my normal process, then let it get all the way through, fully populated and everything, weigh that, enter that weight in, enter the dimensions and that new weight in, and see
what the difference between the recipe is.
Yeah, just without having to necessarily scrap a board, I could at least improve upon, learn more about what it's actually more representative sample, I guess.
That's a unique use case. So we can follow up on that because
Sure.
I don't think somebody's gone after the fact and seen, oh, how far off was I with my bare board?
Okay.
Little DOE there, huh?
Yeah, that'd be fun. Yeah.
So we touched on having a populated board when doing profiling, right, as a best practice. What are some other best practices that folks should be, keeping in mind as they profile, new assemblies in terms of where to attach the probe, how to attach it,
How many?
Yeah.
From our point of view and feedback from our customers, we get a huge range of, I just put, 2 spots, the hottest and coldest points on the board. Usually you want to get front to back, side to side, and the hottest, coldest. But also not just on the components, you got to think of what are in the layers of the board. Do you have ground planes in certain areas and stuff? If it's two-sided, what's the impact when you flip it over on the profile? And then, kind of a cheat you can do is actually do a thermal image of the board as it comes out. Even though it's already cooled, the hottest and coldest spots will still show up.
Sure.
And then you can kind of, rather than just making the assumption, okay, this is a big connector or a big package, so that must be, a key spot. You can actually see, because the board's going to act a little bit differently, just because it's not just where the components are, it's where the layers are, it's what edge is going in first.
Yeah.
All those things that it may not exactly be what you think is the hottest and coldest on the board.
I've become addicted to chasing the KPI, trying to get the best number ever. And what's your opinion on that?
Well, you mean PWI? Is that what you're talking
PWI, yeah. The KPI, key performance indicator, for me is the PWI.
The PWI. So that was something when we were trying to, when we were developing our prediction. So we had prediction software going back to the early 90s, but it was manual. So you could go to top of zone 3 and change it from 170 to 175. And then it would predict. And then you'd just do that, which was a lot better than just trial and error.
Yeah.
And then we're like, well, can we use the power of the processor and an algorithm and search through a lot of profiles, a lot of recipes, right? And say, which one's the best, rather than taking a stab at it one by one. In order to do that, you have, let's say you attach 5 or 6 thermocouples, and you have your ramp rate, soak, reflow time, peak, maybe cooling. You have a huge table of data. Now, how are you supposed to interpret?
Yeah, what's good?
This one's a little bit better over here, but this is, I like this. And you give it to 10 engineers, they're all going to have a different opinion of how good that profile is. So can we kind of turn that to objective instead of subjective? And so that's where we determined that, kind of came up with the process window index, is can we rate this profile, this board, and this recipe, and how good it is on a single metric.
And it basically does that. Tell me if I'm right or wrong here, where it gives you a range of an acceptable criteria, and ideally you're just always going to be right in the middle on each one of those ranges to kind of have the best PWI.
From a kind of basic standpoint of what's a good profile versus a bad one, that's where our starting point is. Okay, you want the nominal or try to target the middle of the process. And then to your question of what's a good PWI, it's relative to your process window, right? So if I have a process window of 230 to 250 on my peak, then that's 20 degrees. Each PWI increment's going to be 5%.
Sure.
If I have a process window, we have some customers where super tight, maybe 235 to 240. So each degree is 20 to 40% PWI. So just a normal variation in the oven can swing your PWI by 20%.
A huge percentage.
So you have to always keep it in terms of, okay, how tight is my process based on the materials I'm using, and then we have even deviations on that, where we have some customers that say, well, I get the best results if I'm on the high side of the peak window.
Yeah.
So and then they're like, well, I want to target 248, because when I hit that on a couple of spots, all my solder joints come out perfect.
Yeah.
So now, and in our software, we have a way of doing that. So the prediction model will not just use dead center; it'll skew your target to where you want it to be.
Okay.
So then you're really getting to being able to
Custom
fine-tune
dial it in.
process. You're like, this specific board, I want to get the best possible. So you're trying to get the best possible solder joints. So some generic process window that the solder paste company gives you, because that's just your starting point. That's not, the paste can actually do quite a bit of different ranges depending on your product and oven. So you start there and then you dial it in where you want your product to be so it's soldered correctly. And we call it, it's like a sweet spot, right? You want the sweet spot for each location to get the best results.
Did I hear correctly that you have a way to integrate with some ovens, actual real-time data of what the actual temperatures are inside of them? Did I hear that right?
Yeah, we take the setup process or the optimization and then turn that into, okay, just like SPI or AOI, right? You have your good result of your prints, right? So you have that established, and now you tell the SPI, okay, this is a good print, right? And now it knows that. Now during production, it can compare and say, well, this one's different, and it's all optical, right? Because you're applying materials, and then it's looking at those materials to see if they were applied correctly. Well, on the oven, there is no materials being applied. It's a unique of the main processes in SMT. It's unique because there is no material. You're applying heat. So what's the best representative to be that golden data is the profile, right? So then well, we can't put cameras in 250C
right
yet anyway.
Right.
Maybe
that'll be sweet when we can.
So then we embed sensors into the oven, thermocouples, we monitor the speed, and then we can track the position of the product.
Because that's what I was thinking about when you talked about like that guy that mentioned, I like a 248, right? And that might be true, but it's all based on that oven particularly, right? Because
in that environment,
his zone, right, might actually be 240, but he's reading 248 on the thing, right? So this would kind of gauge and give you a real time, hey, this is what it is.
And that's what we found early on, because Kick was actually our first product was a monitoring system. I mean, people associate us with profiling and compare us to other profiling companies, but our actual first product was embedding thermocouples. It was at higher temps, so into furnaces up to 1000 C.
Yeah,
they're running at 4 inches per minute.
Yep.
And our founder, he's
got
like,
one of those.
Well, there's a very close correlation to the furnace temperature and the product temperature because it's moving through so slowly. It's almost
Not not some huge delta between
Right.
the set
like
point
on
and
the
actual.
SMT, you're moving fast, so
Right.
the board's never seeing, if your zone's at 280,
Yeah.
the board's never seeing
That's
280. In these situations, it was close. So he's like, well, what if I embed sensors in there? Because these profiles you'd have to trail a wire through that took an hour.
Uh-huh.
He's like, I want to get rid of that. I don't want to do that.
Yeah.
And it's the same now. People, even though it only takes 8 minutes to go through, profiling is a pain. So
I'll have to talk to you about that because we still have those those high temp furnaces for firing up the glazes on compounds on the ceramics, and that's what I've got this. It's this big reel that's like this tall that's on this cart that's got a like a
bicycle wheel?
25-foot long thermocouple on it, and you secure it to that belt that's moving 3 or 4 inches a minute, and it has to be long enough to make it all the way to the the end, and you track it
Then you have
manually.
a hot wire
and
that you have to trail back
recording,
through.
and you're recording the temp at different times. Well, actually, it's like recording like the millivolts and at different times, and then there's a conversion that tells you what the temperature is and all that. But it's pretty wild. So it sounds like you've got something that's a little easier than what I'm doing.
And so we were able to use the profile.
Mm-hmm.
You optimize it, and you have the embedded sensors. And what we've done, and this is kind of early on AI almost, is okay. How can we take that? When you talk about Industry 4.0, it's embedding sensors, doing simulations, and that's something Kick's done for a long time. Is now we have this baseline, just like you do with AOI, some golden data. Then you monitor the sensors during production, and then we can do a real-time calculation.
You're just catching variation
for each production board. So now our customers who are using this, if they're doing automotive, they can have a production run, and for each individual board, they can show their end customer, here's the profile for this, not the one I did once a week, but here's the one I did for this board.
Yeah.
Right.
That's some great traceability.
Yeah. So it really kind of, and internally, not just the traceability for their customer, but internally, it gives them transparency into what's happening in the oven during production.
Can I just say, as like a low volume, high mix CM, and I'm trying not to be too pluggy right now, but thank you so much for the wireless real-time monitoring that hooks up with the SPS. Because with my previous profiler, I didn't know if I clicked the buttons correctly, right? And I didn't know if the battery was going to stay alive, right? And with the new monitoring system, I can literally let it go through and it's kind of wild because I was doing like a glass circuit board and I was doing like a 10-layer board, and I'm profiling these things, and I could see, because my PE was like, you're going to need like 280, 270 on this to even come close. And I'm like, you're nuts, right? But I'm running and then I can see, I'm like, please get more liquidus, please get more, right? Like it's kind of like it was but I could see it in real time. And yeah, it's a 4 or 5 minute profile, but it's still, I'm kind of like, fight my nails during it kind of, but it was really cool to see. And then I know the data's there, right? Like I don't have to guess, and I don't have to.
Yeah, it's a small thing when you look at it. Okay, it's Wi-Fi, right? You should be able to do Wi-Fi on devices. But then you talk about, okay, what added value? I can data log and then plug it in after, but then you don't have that insight. There's that little extra, that, oh, it is going well. Oh, that's what's happening.
Yeah.
As it happens.
Yeah.
Not just a curve after the fact or just a table of data. So it really, and it's wireless, right? When you talk about automation, not just like on our monitoring systems automates, but is there things you can automate on the manual process of running a profile, right? So you don't have to plug in and out, right? You turn on your profiler, plug in the thermocouples, run it through the start of the profile, the stop, the wireless download. You're never having to open up a hot profiler and worry about the manual step of downloading. So any operations, so there's enough technology today, you should have that in a profiler.
That was the wildest part too. When the data was done, it knew it came out of the reflow. Because I'm so used to like glove, right? And you gotta pop it open quick, and it's and you guys got that nice felt. I'm trying not to be, but I'm telling you, it's been an upgrade. You know
No, it's okay. That's okay. You guys have been a supporter of us. It's okay to be a supporter for you guys. And we'll be able to do that later on during the show. We're going to get to come check out what you have going on at the booth and feature a little video about it, and maybe bring some of that into this interview or whatever. But really appreciate you stopping by, taking the time to chat with us. This was
Love
a lot
to
of fun.
have like a nice open conversation.
Yeah, it was good.
Inquisitive.
Yeah,
Awesome. Thank you,
Didn't throw
Miles.
me off my game too much.
No,
It'd be
good.
hard to.
Well, thanks, Miles. Hope you have a great show.
All right. Thank you.
Thanks.